Hey everyone, here we have a good question from our exam review for grade 10, and this is a linear systems question. So it says the sum of the digits of a two-digit number is 7. When the digits are reversed, the number is increased by 27. Find the number. Okay, so there's a couple ways we can do this. The first way I would say, if you're completely confused and have no idea how to set this up, that's okay because it's a pretty tough question. Trying to figure out, what to make X and what to make Y or things like that. But if we just start with the first part of the question, the sum of the digits of a two-digit number is 7. There's only a few combinations of that, right? You can have 3 and 4, 1 and 6, or 2 and 5. So those are the only, or 7 and 0, I guess. 70, but not 0, 7. So there's really limited combos that you could actually just guess and check and try them out and see if the numbers actually increase by 27. But markers don't always like that. If it's not a multiple choice question, we're probably going to have to show some work. So let's see if we can write down what we know. The sum of a two-digit number is 7. And I actually didn't write it down here, but it's supposed to say the sum of the digits. So let's pretend our number is x, y. So this is not x times y, this is just the number. So if it happened to be, let's say 16, then x would be 1 and 6 would be y. So these are just like placeholders for our digits. So x and y are the two digits we're looking for because really that's all we need to solve the question. So I'm going to take the first sentence there. It says the sum of them, those two digits, x and y, are 7. So right there we have an equation. We know x plus y must equal 7. Perfect. So we've got one equation and two unknowns. Now we need another equation with x and y from the other piece of information that they give us. So it says when the digits are reversed, the number is increased by 27. Okay, so that's tough. But let's think about what each of these digits mean. So this x is in the tens place, this y is in the ones place, right? So if we think about if we just had x and y on their own, let's actually use this example. If we wanted to say, okay, what's the value of the number that x and y have together right now? We know it's 16, but if we just knew x was 1 and y was 6, how would we do that? Well, that's saying it's 10 times 1 plus 1 times 6, and that equals 16. So all I'm doing is I'm multiplying the number that's in the tens place by 10 and the number that's in the ones place by 1. Okay, perfect. So let's set up the number we have right now. I'll do the other equation in red as well. So the number we have right now when it's xy is 10x plus 1y. That's the value of the number when it's ordered xy. But now we say, okay, that number is going to go up. It's going to increase by 27 to get to the number when it's reversed. So when it's reversed, it's the exact same thing, only y is in place of x, and vice versa, times 1x. So hopefully that's clear, right? This is the setup of the number we have right now when x is in the tens and y is in the ones. And then the problem tells us that if we move the y number to the tens place and the x number to the ones place, it's going to increase our initial number by 27. Now it looks like we have two equations, two unknowns, just the x and the y. So I'm going to do some algebra with this second equation. I'm going to bring everything to the left side. So I'm going to say it's 10x minus x plus y minus 10y plus 27 equals 0. This simplifies to 9x minus 9y plus 27 equals 0. So now I'm going to call this equation 2 because it's nice and clean now, and this equation 1, and it's just a systems of equations. So I'm going to use substitution, and the reason I'm going to choose substitution is because this first equation, equation 1, is set up nicely because there's no coefficients in front of x and y. So I'm going to say x here equals 7 minus y. I'm just subtracting the y over. Then I'm going to sub this in for x into my second equation. So I get 9 instead of x, it's 7 minus y minus 9y plus 27 equals 0. This simplifies to 63 minus 9y plus 27 equals 0. This simplifies to negative 18y plus 90 equals 0. So if I add 18y to the other side, I get y equals 90 over 18, which equals 5. So I know my y digit is 5. If they have to add up to 7, I know my x must be 2. So x equals 2, y equals 5. So the number currently that we were asked for is 25. Again, this is a difficult question because we don't really know how to set it up. We probably could have figured out 25 in our head, right? 25, if we reverse it, it becomes 52, which is 27 bigger than 25. So it does work. And again, we probably could have figured that out just through guess and check. But whenever we're using digits in a number and trying to find the value of that number, we must think about what place they're in. So x is in the tens place, y was in the ones place, so that's why we multiplied it by 10 and 1. Hopefully you found this helpful. You can always reach out to us, info@arnoldtutoring.com, if you have any other questions. Otherwise, best of luck on your exam. Thanks.